Gottfried Leibniz was a German mathematician who developed the present-day notation for the differential and integral calculus. His philosophy is also important because he wrote journal articles about sufficient reason, which led to his invention of a calculating machine called the step reckoner. His father died at an early age, leaving his mother to raise him all alone, but her teachings influenced his philosophical thoughts in his later life. His father had been a professor of moral philosophy at the University of Leipzig, so he inherited his father's personal library. He was given free access from the age of 7 and thereafter. While in school, his work focused on a small canon of authorities. His father's library enabled him to study a wide variety of advanced, philosophical, and theological works. Leibniz may have been the first computer scientist and information theorist. Early in life, he documented the binary number system, base 2, which is used on computers. He anticipated algorithmic information theory, which is associated with mathematical computation, and his calculus Ratiocinator anticipated aspects of the universal Turing machine. In 1934, Turing claimed to have found a mention of the concept of feedback in Leibniz's writings. While mulling over his binary arithmetic, Leibniz imagined a machine in which binary numbers were represented by marbles, governed by a rudimentary sort of punch cards. Modern-day digital computers replace Leibniz marbles with voltage gradients, shift registers, and pulses of electrons, but otherwise they run roughly as Leibniz envisioned in 1679. Leibniz believed that much of human reasoning could be reduced to calculations, and that such calculations could resolve many differences of opinion. He states, "The only way to rectify our reasonings is to make them as tangible as those of the mathematicians, so that we can find our error at a glance, and when there are disputes among persons, we can simply say, 'Let us calculate, without further ado, to see who is right.'" His calculus Ratiocinator resembles simple logic, which is a treatment of formal logic in which a system of symbols is used to represent quantities and relationships. There are two contrasting points of view on what Leibniz meant by it. The first is associated with computer software and the other with computer hardware. The received point of view in analytic philosophy is that it anticipates mathematical logic. The analytic point of view understands that this is a formal inference engine or computer program which can be designed to grant primacy to calculations. A contrasting point of view stems from synthetic philosophy and fields such as cybernetics, electronic engineering, and general systems theory. The synthetic view understands it as a calculating machine. Norbert Wiener even considered it a forerunner to the modern-day digital computer. In relation to the calculus Ratiocinator, the I Ching, which is a classic Chinese text, was centered around the ideas of the dynamic balance of opposites, the evolution of events as a process, and acceptance of the inevitability of change. However, Leibniz deemed this kind of text unrealistic. Leibniz constructed such a machine for mathematical calculations he called a step reckoner, which was a digital mechanical calculator. It was the first calculator that would perform all 4 arithmetic operations: addition, subtraction, multiplication, and division. As a computing machine, the ideal calculus Ratiocinator would perform Leibniz's integral and differential calculus in the way the meaning of the word Ratiocinator is clarified and can be understood as a mechanical instrument that combines and compares ratios. Leibniz thought symbols were important for human understanding. He attached so much importance to the invention of good notations that he attributed all his discoveries in mathematics to this. C.S. Peirce, a 19th century pioneer of semiotics, shared Leibniz's passion for symbols and notation, and his belief that these are essential to a well-running logic in mathematics. But he took his speculations much further than this, defining a character as any written sign. He then defined a real character as one that represents an idea directly and not simply as the word embodying the idea. Some real characters, such as the notation of logic, serve only to facilitate reasoning. Instead, he proposed the creation of a universal characteristic, which is a formal language able to express mathematical, scientific, and metaphysical concepts. He states, It is obvious that if we could find characters or signs suited for expressing all of our thoughts as clearly and as exactly as arithmetic expresses numbers or geometry expresses lines, we could do in all matters insofar as they are subject to reasoning all that we can do in arithmetic and geometry. For all investigations which depend on reasoning would be carried out by transposing these characters and by a species of calculus. Complex thoughts would be represented by combining characters for simpler thoughts. He saw that prime factorization suggests a central role for prime numbers. However, Leibniz's idea of reasoning through a universal language of symbols and calculations foreshadowed great 20th century developments, such as Turing completeness, which are the rules that's followed in sequence that can produce the result of any calculation. Because Leibniz was a mathematical novice when he first wrote about the characteristic, he did not conceive it as an algebra, but rather as a universal language or script. Only in 1676 did he conceive of a kind of algebra of thought, modeled on conventional algebra and its notation. The resulting characteristic included a logical calculus, algebra, geometry of situation, and a universal concept language. What Leibniz actually intended by his universal characteristic, calculus ratiocinator, and the extent to which modern formal logic does justice to the calculus, may never be established.